Okay, here we go, coming back to schedule management. So we're picking it up with schedules with some things to watch out for. One is Parkinson's law. So if you give an activity 2 weeks to do something and they finish it in just a week, it says, you know what? The activity owner might say, I'm just going to sit on it. I'm going to redo it. I'm going to do something else, right? That's Parkinson's law. So the other thing to watch out for when it comes to schedule management is student syndrome, right? What do students do? Hey, no offense meant on you guys. You'll wait till the last minute, do an all-nighter, and get the report done. Oh, excuse me. So that's called student syndrome, and sometimes your activity owners will do that too. If you want a good treatise of that, you could pick up the book called Critical Chain. It's by an author named Eliyahu Goldratt. He's since passed now, but he wrote in Critical Chain about things like Parkinson's law and student syndrome. And it's written kind of like a novel of schedule management, so that's kind of interesting. It's an interesting approach. I think you'd enjoy it. Okay, so let me go back to full screen. There we go. So we're looking for the critical path here, right? We've got now these nodes with the dependency arrows, and somewhere in there, and precedence and successor activities, right? Notice that A is not a precedence activity or successor to H, right? Not related, but the dependency arrows show the others along the way. And so what we're doing is we're going to add our activity times and look for the critical path. Remember, those are the activities that have no float or slack, no extra time built in. If that activity delays, the whole project delays. So you can see that any activity with zero float is a critical path. So already I'm looking at this and I'm going, okay, critical path is, so here critical path is D, critical path is J, and critical path is N. That's the critical path because there's no float. So notice in these times, if I subtract the bottom one minus this one or this bottom, it doesn't matter. Either side, if I get zero, there's zero float, and that's part of the critical path. Okay, and we'll define those here shortly. And another way to say it is just called slack, right? And so notice the activity is supposed to be 20 days. So if the project starts at day 0, all these first 3 activities start at day 0. And then you add 20 days to it, and the early finish is day 20. Well, that means that this activity begins on day 20, and it's 15 days long, so it can end on day 35. Well, if it ends on day 35, this activity can start on day 35. It has an 8-day duration. It will end on day 43. Well, if it ends on day 43, the ending might be able to begin on day 43 also, right? And there's no duration here, so it not only begins, it also ends on the same day. And that's called the forward pass. Now to do the backward pass to get the bottom numbers, instead of adding them up, you subtract them. So 43 minus 0 for this activity is still 43 for the late start. And then I have to put the late start into each of these, because notice it's going backwards from its dependencies. Well, this one is 43 minus an 8-day duration is a day 35 late start. And now day 35, because of the dependency arrows following them backwards, will go into here. And the rest works out that way. Okay? And whenever you have zero float, this is called your late start minus early start, or late finish minus early finish. As long as it's 0, you have zero float. Here's kind of they put it in a table format. I don't really use the table format. The book does describe it well. That's up to you. I would rather just figure out the slack by putting a number right here at the bottom of each activity. When I subtract either these two or these two, If it's 0, then I'm on my critical path. Okay. So notice though that this activity has predecessor and successor activities, right? We've talked about that. So those predecessors, successors can be finish to start, start to start, finish to finish, or start to finish. And so we generally work on, and if you ever sit for the PMP certification exam, you will only do mathematically finish to start. That's the most common. I must finish this before I begin these. I must finish B before I can begin D and E. That's finish, or D. I must finish B before I can begin E and F and G. Well, I will finish C before I begin E, and C goes to F, and C goes to G, and C goes to H. Now there's a little bit of a problem here. E must wait on both C and B to finish before it can start, right? And you can see that C ends on day 10, B ends on day 20, and that's why you have to wait for both of them. And that's why E begins on day 20. Because sure, I could have begun on day 10, but not really. I need B to be done also. And that's why you have to wait for the longer time. And that's a finish to start relationship, right? And so the basic formula is the predecessor must finish before the successor can start. The definition here is the predecessor must start before the successor can start. Here the definition is the predecessor must finish before the successor finishes. And here the predecessor must start before the successor finishes. That's a rare odd use case. This finish to start is the most common. Now here's what that same precedence diagramming method or activity on node would look like in a Gantt view. That's all. Okay. A Microsoft project will spit out these tables. I generally don't use these tables much, but notice we're going to do PERT here because we have an activity ID, the activity name, which we've been using in our schedule network diagram, our predecessors, right? So I know the relationship. I could build that schedule model knowing all this. Then I have the most likely, optimistic and pessimistic times. And when I multiply the most likely by 4 and add optimistic and pessimistic and divide by 6, I come up, I'm using the same formulas from cost management. I come up with my expected duration for each activity. Here is that duration shown in a Gantt chart again. And this would be the same showing it in activity on node. Still, it's the CPM method, right? The activity is happening here. We have dependency arrows. So we're going to talk just in terms of critical path method. Now, Microsoft Project will put this in terms of a calendar. I like that, but not really necessary for this course. It's a nice tool to use. We do assume these activities are statistically independent, except for the predecessor, successor activities, the relationships. Those are the relationships that the work breakdown structure and scope does not show you. Now those dependency arrows show you the relationships in predecessor and successor activities, right? And I can determine if I want to, using PERT, again, variance along the critical path. And they give you some formulas. This is treated well in the book, so I would go there for that. And the key here is we want realistic estimates. Realistic estimates reduce your risk. And we've said waterfall or predictive project management, which this is all about, is risk driven. It's about reducing risk of falling behind, being over budget, or not hitting scope. Okay? Now, we'd mentioned simulation. Simulation is a powerful tool. And you plug all your variables, your constraints, those activity times in, and it will figure out your critical path for you. It will figure out when your project will likely end. So you see this is a bell-shaped curve, and the mean is right in the middle. So it's most likely that the project will end around day 46. That gives you something to work from when you're developing your own schedule and comparing estimates of activities from other people around the team. And so you can do the same with cost analysis. You can see we're going to do PERT again based on cost. So PERT can be applied to cost or schedule. It's a good tool to reduce risk to your project to get a better estimate. And of course you weight the most likely by a factor of 4. So it's optimistic plus 4 times the most likely plus pessimistic divided by 6. And that's your PERT estimate, whether it's cost or schedule. Cost, of course, is going to be in dollars, schedule in time, but you can convert schedule to dollars also, right? Time is money, is it not? And here's an analysis of that simulation. Again, notice the bell-shaped curve, and in the middle of this is a symmetrical bell-shaped curve, which is important. When it's symmetrical, we can count on the mean or the average right here in the middle. Average and mean are a little different, but not enough for this course. And so we can count on that as in terms of cost using our PERT estimates. And this is what the simulator is also going to give you. Now, simulation is recommended, but only after we've done our own due diligence in developing our schedule and cost estimates. We want it to affirm, not to create for us, right? And a project manager is going to do schedule network analysis. That means it's important for you to manage all the paths and to understand them. And before the schedule goes final, look at the other options that might be available for certain activities or precedents, even for non-critical tasks along the way. There are multiple tools you can use. We've seen here Microsoft Project, this Crystal Ball, and Excel. I will add that one other, which is Smartsheets, which is frankly Excel on steroids. It's frankly a low-cost, highly capable middle ground between Excel and Project. Really great. Okay, that's it. I enjoyed it. I will see you online.